we need to go over this as quickly as possible. So the first assumption is that yesterday you copied this down, so all I have to do is just talk about it. Right? Now, first thing, you need to know that in statistics, sometimes we may need to divide the data set into groups. Okay? So we've got what are called quartiles. Now, these quartiles, they are actually, let's not waste time, please. So far, we have lost 10 minutes. We have lost 10 minutes now. All right. So in statistics, there are times when we may need to divide a data set into groups. Okay. Now, we have got what are called quartiles. Now, the prefix, okay, from your English, the prefix quarts, it comes from the word quarter. Okay? The prefix of the word quartile, that is quart, comes from the word what? Quarter. So quartiles divide a data set into 4 equal parts. The quartiles, they divide a data set into 4 equal parts. Okay? Now, we have got 3 quartiles actually. Okay? And they are Q1, which is called the lower quartile, Q2, which is called the median, or if you want, you can just call it Q2, okay, or you can call it the middle quartile, right? So Q2 is actually the median of a data set. It's also called the middle quartile. Then you have got Q3, which is the upper quartile, right? Now, when you are given a data set, usually I'm talking about a large data set, maybe say 20 values or more, you can put them into groups of 4 each, right? So you've got your first quartile, right, that is the first 25% of the data set. Your second quartile, that is the first 50% of the data set. Then you've got your third quartile, which gives you the first 75%, and it also gives you the remainder, which will be 25%. So any data set can be divided into those quartiles. Now, it's very important for you to know that the middle quartile is the median. Now, you cannot find the quartiles without arranging the data set in ascending or descending order. So whenever you have your data set, you have to arrange it first from the smallest to the largest or vice versa. And then you can then determine your quartiles. In most cases, you actually have to arrange the data set from smallest to largest. That's the most common way of arranging the data set. So that's what we have here. Then, now, with any data set, there are 5 values that are extremely important. And those 5 values, we call them the 5-number summary. Now, the 5-number summary are made up of the minimum value, the lower quartile, Q2, which is the median or the middle quartile, and also your upper quartile, which is Q3, and then the last one will be your maximum value. All right? Yeah, then. All right. Okay, so make sure you are familiar with this 5-number summary. Now, yesterday, when I showed you how to use a calculator, right? When I showed you how to use a calculator, all these 5 values here, they can be determined by your calculator. All you have to do is just retrieve them from your calculator. Unfortunately, some of you don't have the calculator which can do it, and that's beyond Mr. Chiponda's okay, it's beyond me. Now, what will happen is that in the case of your trial examination, if a question comes on the 5-number summary and you're supposed to determine them, you are going to take longer as compared to someone who already has the calculator. Right? Then you can end up wasting time. Okay, I'm just going to show you how to find the 5-number summary. Okay, quickly. All right, allow me to just use 1A to determine the 5-number summary. Right? All right. The data set is already arranged in order here. It's already arranged for us, so it's easy. But if the data set is not arranged, you need to arrange it. In most cases, I advise you to arrange it from smallest to largest. So it says find the 5 numbers summary for each of the following data sets. We don't have time to read for all 4 sets of data. We just choose one. The concept is the same, right? So let's start with the minimum. So the minimum, obviously, the minimum is going to be 1. Okay? The minimum is equal to 1. Okay? You can also write here the maximum is going to be equal to what? 51. Okay? At this stage, I'm just doing it based on the order of difficulty to find. So your minimum and your maximum, they are very easy to find. All right? Then, if you want to determine the lower quartile, the median or the middle quartile and the upper quartile, I suggest that you find the median first, because the median divides the data set into 2 equal parts. So we need to count how many values do we have here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 of them, which means if I want to find my median, I have to identify 2 values in the middle of the data set. And those 2 values are going to be the 8th value and the 9th one. But based on the formula which I gave you yesterday, I say for an even data set, the median position, you can determine the first value in the middle of the data set, then you also consider the next one, which is after it. So this will be n over 2. Now, n over 2 is going to give you 16 here over 2, which is what? 8. So if you count 1, 2, 3, 4, so our 8th value is that, right? Since the data set is even, it means we also need the 9th value. So that we have got this data set is even. So that the first 7 values are also the same as the last 7 values. If the data set is even, you need to identify 2 middle values of that data set. Are you following that? Right? So our median, which is also Q2, so I'll write here Q2 in brackets, which is the middle quartile, or it's also the median. So I'll say 24 plus 33 all over 2, so you get 57 over 2. Now if you divide here, you get 28,5. Okay, please, you don't round it off. Please, you don't round it off. So just write it as it is, 28,5. Then, if we want to find the lower quartile and the upper quartile, okay? Now, I'm sure you can agree with me that the first half of the data set is going to include 24. Am I right? Yeah? Yes. And the second half of the data set is going to include the 33. So if I want to find the lower quartile, I just have to find the median of the first half of the data set. Okay? Sorry for that. Okay? I'm going to repeat this. If you want to determine the lower quartile, you need to know that the lower quartile is the median of the first half of the data set. So how many values are part of the first half of the data set? It's 8. Okay? There are 8. So if you have got 8 values, it means our data set is even, so we identify 2 middle values. So those 2 middle values are going to be 9 and 15.
So I want to say the number 3 is 3.5. This is what the data set.
Okay. Yes, it's not part of the data set, yes. But because our data set is even, we are approximating where the median is. Even though the answer is not a positive integer, we have to take it as it is. We don't have to round up because it's just an approximated answer. Using this method, we are approximating the median, okay, based on the given data set. Okay. All right. So I'm saying, please, I'm going to repeat this. The lower quartile, Q1, is the median of the first half of the data set. Okay? So if you've got a full data set of 16 values, the first half must have 8. So out of those 8, we need to find the median of those 8 values. That median will be our lower quartile. Since there are 8, you count from 1 up to 24. It means if I want to find the median, I have to locate the 4th value and the 5th value. Then I have to add the 2 and divide by 2 to get the lower quartile. So here I'm going to write here Q. Please, I'm not going to write lower quartile. I'll just write Q1. Q1 is going to be equal to 9 plus 15 all over 2. This will be 24 over 2, and that's 12. Okay? So that's Q1, that is the lower quartile. The lower quartile is the median of the first half of the data set. The median itself of the full data set, that is Q2, is the median of the full data set. Okay? All the values, the median is Q2. But if you want to consider the lower quartile is just the median of the first half, then Q3 is the median of the second half of the data set. So again, I'm going to identify, I'm counting 1, 2, 3, 4, and then this will be my 51, so I need the average of those two. Now, fortunately, the 4th value of the second half of the data set and the 51, they are the same. Therefore, my Q3 is going to be what? 38. There's no need for a calculation because 38 plus 38 divided by 2 gives you what? 38. Are you following there? Right? So these 5 values, 1, 51, 28,5, 12, and 38, they are called the 5-number summary of this data set. We need them if we want to draw what's called a box and whisker diagram so that we can analyze the distribution of the data set. Okay, it's part of what I call measures of dispersion. Okay, we'll draw a box and whisker, but maybe, okay, okay, I'm gonna draw it later on. Yes, so you can get, now, listen, can I have your attention, please? Now, since I showed you how to use the calculator yesterday, now these values, if you've got a good calculator, you can just retrieve them from the calculator. You don't have to stress about how to find them manually. Okay? I have determined them manually here, but your calculator can give you the values. All you just have to do is press shift, then 1, then you go to the correct option. You press equals, you get your value. I showed you yesterday. Okay? All right? Right. Any questions so far? Questions? Right. Let's move on. All right. I'm not going to spend too much time here on percentiles, but you need to find some time to sit down and you can read about this. Now, the word percentiles, I'm sure you can see that we have got a prefix there, which is what? Percent. All right? Percent means per 100. Okay? So, percentiles can divide a data set into 100 equal parts. All right? Now, among the percentiles, Okay, we can also convert some of the quantiles to percentiles. So your lower quartile, which is about 25% of the data, it will be the 25th percentile. Your median, it will be the 50th percentile. The upper quartile, which is Q3, it will be the 75th percentile. So you can also read about that here. Okay? But what it's also important for you to know that between quartiles and percentiles, the quartiles are more important. Generally, your examinations, they test you on knowledge of quartiles. Okay, so you can read this. Then measures of dispersion. Hey, measures of dispersion, right? Now, you were taught in grade 8 and 9 some of this, okay? When I say some of this, I'm referring to the range. So, your measures of dispersion, they just tell you how spread the data set is. Usually, it will be from the mean, okay? The measures of dispersion, they just tell you how spread out the data set is. How far apart is the data set from each other? Okay? And in most cases, our reference, all right, so the range is just a value you get by subtracting the largest, or rather, you subtract the smallest from the largest. So your range is equal to the largest value minus the smallest value. Okay, it is very straightforward. Okay, now this one now, it doesn't take into account the distribution of any other piece of data, except it only focuses on the smallest and the largest. All right, then we also have what's called the interquartile range. Now this one is very, very important. Okay, later when you talk about grade 11 stats, we are going to need to know the interquartile range. Right? So your interquartile range is just the difference between the lower quartile and the upper quartile. So the IQR, okay, can I have your attention, please? Can I have your attention? The interquartile range IQR is always equal to Q3, that is the upper quartile, minus Q1. Please, if you are not paying attention, when I introduce the grade 11 part and I start talking about this, you are going to end up having problems. Okay? Please do yourself a favor. Pay attention. Pay attention. So your interquartile range is the difference between the upper and the lower quartile. Okay? Now, this one here is very important because it is not affected by what are called extreme values or outliers. Okay? Extreme values in a data set are values that are out of the normal. Like, for example, you write a test, most people get marks up to 70%, and then there's only one person maybe who gets 90%. That person who has got 90% is actually an extreme value as compared to the rest of the class, and we call that value an outlier. So the interquartile range, generally, it is not influenced by extreme values, whether they are small or they are very large. Now, we also have a sister of the interquartile range, or a brother, if you want to call it that way. It's called the semi-interquartile range. Now, the semi-interquartile range is just the average, okay? Or we can say it's just the average of the difference between Q3 and Q1. So, Q3 minus Q1, if you divide that answer by 2, you get what's called the semi-interquartile range, okay? SIQR. Okay, if you want, you can just denote it as SIQR, semi-interquartile range. Okay? Now, the semi-interquartile range generally is not as important as the interquartile range, but it is also one of the measures of dispersion. Right, now let's talk about the box and whisker now. Now, the box and whisker, okay, it is just a, okay, I would say a graph, or if you want to say a diagram, okay, let's call it a diagram, not a graph. Now, a box and whisker diagram is just a diagram that you can use in order for you to determine the symmetrics of the data set. That is, how spread is the data set usually from the mean. So it can help you to determine the distribution of the data set. You can determine what's called the skewness of the data set. How much is the data set skewed to the left, usually of the mean, or skewed to the right of the mean? Okay, so the box and whisker diagram, for you to be able to draw it, you need your 5-number summary. Okay, so you need your minimum, then you need Q1, you need Q2, you need Q3. You also need the maximum value. So you have your minimum, and then the lower quartile, your middle quartile, which is the median, and then your upper quartile, and then your maximum value. So what I'm going to do, because of my time, can I have your attention? Can I have your attention? I'm only supposed to have 2 lessons to go over this grade 10 part. So in your own time, can I have your attention? Can I have your attention? As an exercise that you do at home, you must attempt these questions here. Okay? But I'm going to show you how to draw the box and whisker based on this data set here. Remember, I found the 5-number summary here. Okay? I found the what? The 5-number summary. So I'm going to draw a box and whisker based on this 5-number summary here. So allow me to go to the next page. Now, when you are drawing your box and whisker, you need to have a number line first. You need to have a number line first. Okay? So if I look at my values here, my minimum is 1, my maximum here is 38. Okay? So allow me to just draw a nice number line. Okay? Okay. The maximum is 51. Alright? So minimum is what? Is 1. So what I can do here is I'm going to just have maybe my 0 here, and then I'll say 10, and then 20, 30, then 40, and then 50. Please be aware that I'm using my eyes to calibrate my number line here. So it's not that perfect. Alright? Okay. Let's start with the minimum. Let's start with the minimum. So our minimum is 1, which means if I want to locate where 1 is, it's very close to 0. So I'm going to put a dot just on top of it. Let me put the dot somewhere there. Okay, that's for the minimum value. Right? Then our lower quartile here, that is Q1, is 12. Now 12 is to the right of 10. Okay, so here we have 15 here, so I can say 12 is somewhere there. Now, when you, okay, listen, by saying box and whisker, okay, the quartiles are part of the box. Then the maximum and minimum are going to be part of the whiskers. All right? So I'm going to draw a vertical line, okay, like that, right? Now this vertical line here, it will represent the position of the lower quartile. Then let me identify my Q2, it's 28,5. So if I go to 30 and then move to the left of 30, then I'm going to approximate it, so it will be somewhere there. Now, the length of this of the line which represents the lower quartile must be the same as the one for the median. Okay, please, I don't have a ruler, so I'm just approximating. Right, but you will have a ruler, so you must make sure that the length of this vertical line here, which represents the lower quartile, is the same as for the median. Then our Q3 is 38. Alright, 38 is very close to 40. So I'll just draw it like that. Alright? Then I'll draw my box. Okay, that's my box there. Right? Then I'm going to join the box with a whisker, right? So that will be the whisker there. Then I've got a second whisker for the maximum. Please allow me to just put 60 here. So 51 is just above. It's just above. Sorry, to the right of 50. If I approximate it, maybe somewhere there. Then I have to join and then join them. Right? Oh, sorry, I made a mistake there. Supposed to be the whisker. So my whisker supposed to join it like that. Okay? Right. Listen. Okay. Let's label this box and whisker. Let's label it. So this is our minimum. That's Q1. That's Q2. And then we have got Q3. And then we have got our maximum. Okay? So this is the box and whisker diagram. You can get a question in your trial exam, final examination, asking you to draw a box and whisker. What's wrong with you? Huh? Right? So a box and whisker diagram is used to determine the distribution of the data set, whether the data set is symmetric or it is skewed to the left, okay, or it is skewed to the right. Okay? Now, our point of reference, okay, is always the mean. The mean is the one which is our point of reference when we are talking about the symmetrics of the data set. If the data set is symmetrical, it means that it will have a shape which looks like this. It's called a bell shape. Okay? Now, it can be skewed to the right, which means most of the values can be to the right of the mean. Okay? Or it can be skewed to the left. Okay? So a box and whisker, it just helps us to do an analysis on the distribution of the data set. How spread is the data set? Usually from the mean. The mean is our reference. Okay?